So in this lesson, we're going to talk about average rate of change, and it shouldn't say average rate of change, also known as the slope, and often m will be used as our variable for slope. But we may be introducing some new notation. You probably remember this equation for slope from your previous algebra classes, y2 minus y1 over x2 minus x1. But you may not have seen this notation. Delta y is the difference between the two y values, and delta x is the difference between the two x values. So really this y2 minus y1 is actually delta y, and this x2 minus x1 is delta x. And in mathematics, the term or the symbol delta is used to reflect a difference or a subtraction problem of some type. All right, so let's look at an example of finding an average rate of change. And I'm going to see if I can't make this window a little bigger. If not, I'll just move it. Yeah, I'll just move it to read the problem here. Okay, so near the surface of the moon, the distance that an object falls is a function of time. It is given by d of t equals 2.6667 t squared, where t is in seconds and d of t is in feet. If an object is dropped from a certain height, find the average velocity of the object from t equals 1 to t equals 2. And again, I'm going to try to make this a little bigger. And there we go. I wanted you to be able to see the whole problem. All right, so an average velocity is an average rate of change. Think of velocity as the rate at which distance is changing in respect to time. So average velocity, average acceleration, average speed, those are all average rates of change. So we're going to use our formula, our slope formula from algebra, to find this average velocity. But first, we need to get y values. We've got essentially x values because our t is really our x here. It's just called t instead. So to find our y values, let's plug a 1 and a 2 into this distance formula. So I'm going to go ahead and do that first. So d of 1, and it's capitalizing my d, is going to be 2.6667 times 1 squared. And if I put that into the calculator, well, of course I don't really need to. I'm going to have 2.6667 times 1, which is 2.6667. Now let's put the 2 into our distance formula. 2.6667 times 2 squared, which is really 2.6667 times 4, and I'll put that into the calculator. All right, and that gives me 10.6668. Okay, so I've got my x values, I've got my y values. If I want to, I can write these as points, and you might find that easier when using that slope formula to have them written as the 2 points that they are. And let's use that slope formula from algebra. Now let me move this up a little bit. So we're going to say y2 minus y1, and I'm just going to use m because it's easier to type, it keeps capitalizing it, than delta y over delta x is. Top of the fraction, I'll have y2 minus y1. So my second y value is the 10 minus the first y value. And then on the bottom of the fraction, we have to make sure that we start with the x value that goes with the y value we started with. So we got to start with the 2 on the bottom. And we get whatever 10.6668 minus 2.6667 is. So on the top, I get 8.0001 over 1. And chances are in our homework, we're going to round that off to about 2 decimal places, which is really just going to make it 8. Now, all average rates of changes have units when dealing with an applied problem like we just did. When we talk about velocity, if we're going down the road, we say we're going 60 miles per hour. There are two units there. There's the miles and there's the hour. So when we talk about velocity here, let's notice this distance was in feet. So this is feet per, and our time is listed in seconds. So feet per second. 8 feet per second.